Good morning, everybody. I am really excited to start off this discussion of new genetic tools with you guys, starting off with our most recently introduced trait, which is milking speed. So as I started to put this presentation together, and I was thinking about it, what really stood out to me was how this trait is really a story of both collaboration and innovation. And I think that's a really good story to tell as CDCB. So first of all, on the collaboration side, most importantly, the collaboration of our dairy producers being willing to compile this data, contribute it to the database and for research is really the most important thing that made this possible. I'll get to it in a couple of slides, but we also had a milking speed task force, which was composed of members throughout our industry partners, and everyone was putting their heads together to come up with solutions to make this a reality. This research required an agreement between DRMS and USDA Agile that really allowed us to lay the groundwork in the research. And then, last but not least, we always talk about this, but I felt like it was important to mention on this trait as well. We have to coordinate between USDA Agile and CDCB to take that research into a production phase. So then if we look on the innovation side, we knew pretty quickly that a subjective score, similar to what a lot of other countries use for milking speed, just wouldn't work and wouldn't scale to the size we needed to use in the US. So we were going to have to come up with something else. Given that we are coming up with something else, we're going to need new data formats and new infrastructure in order to handle that data. We're going to use ultimately deciding on individual milkings and durations. We're going to have to store that data somehow. All of this stuff had to be developed in order to make this milking speed evaluation a reality. So with that little quasi-introduction, I wanted to start off with the basics. What is milking speed, and why would we want to select for it? So at its most basic, milking speed is a measure of milk flow rate. And we can measure that in a number of different ways. We can talk about the duration of time that she takes to milk out. We can talk about the time that it takes for her to reach peak max flow. We can talk about average milk flow. What we decided to use in the US was pounds of milk per minute taken from every single milking throughout a lactation, averaged across that from days in milk 10 through 305 in a conventional milking system. Essentially, we're not using data at this time from automatic milking systems. So then our next question was, why would we want to select for milking speed? And essentially, it's an opportunity to optimize the parlor efficiency by reducing the time it takes for cows to milk and thereby reducing the labor costs. What we heard from producers and from the industry as a whole was that this trait of milking speed was getting increasing interest, throughout. And so we wanted to go in and investigate what we could do about that. With this knowledge, the CDCB board created the Milking Speed Task Force, and this was formed late in 2021 with representatives, as I said, from many sectors across the industry. Our chair was Dr. Asha Miles from USDA Agile at the time. We also had representation, of course, from CDCB, but also purebred associations, NAAB, the DRPCs, and National DHIA. And when this Milking Speed Task Force was created, the main broad questions that we were posed were, is a milking speed evaluation possible? And if it is possible, what are we going to need to make it a reality? So that brings us to the research going behind these evaluations. With the first meeting of the task force, we had a lot of questions. So how do other countries measure milking speed? We know they do, but how exactly are they doing it? How do we, the US at a national scale, want to define a trait of milking speed? What system effects are influencing milking speed? Are there things like the manufacturer that we need to be aware of and take account of? What biological factors are impacting milking speed? Things like parity and breed. Do those impact the cow's milking speed? Ultimately, what data do we need? And maybe more importantly, what data are available to make this happen? So if you flash back to this time last year, Dr. Asha Miles gave a great presentation about the research going into these evaluations. And the great thing is that she answered pretty much all of these questions in that presentation. Now, if you're like me and you don't remember what you had for breakfast yesterday, you can go to the CDCB YouTube page and relive this presentation in its entirety, but I have the Cliff Notes version for at least our questions at this time. So other countries measuring milk speed. Most other countries, most other breeds, are only using a subjective score. It's usually part of the type classification. How do we define milking speed? So we've decided to define it as pounds of milk per minute. What system effects do we need to account for? Well, we found that we need to account for the milking frequency, the milking session number, and the meter manufacturer. The biological effects that we need to account for are things like parity and breed. So in addition to all of these factors that we need information on, ultimately we need data on individual milking yields and those individual milking durations. We were fortunate to have a research collaboration with DRMS where they compiled over 50 million individual milking records from approximately 300 farms across the US. Now, this was the raw sensor data coming into us. And this data required a lot of editing and cleaning in order to ensure that we have the best data going into the National Genetic Evaluation. And the USDA ADL team spent a lot of time developing and testing these specific constraints that we would need to place on this new source of data. Once we put those editing constraints in, the data going into the August evaluations amounted to over 146,000 cow lactations from about 132,000 cows in 215 herds using 10 different meter manufacturers. The really exciting part of this trait, at least from the geneticist point of view, is it has a really high heritability. So the heritability for milking speed was estimated to be 42%. So if we compare that to something like our production traits, something like milk yield, that heritability is 20%. When we go even further down, we start talking about our functional traits, we're getting down to less than 10%. And what this leads to is that even with a fairly modest data set with 146,000 records, we can get relatively high reliabilities already at the start. So our proven bull reliabilities are averaging 68%, and our young bull average is about 59%. So once the research stage is done, that's not the end of the story by any means. So that research and development has to move on to our operations team. And that's where the trait undergoes lots and lots of testing. So we said that this is the first trait that has used sensor data at CDCB, and it required a new data format to be developed. All of that data format, all of that coming into our system, the DRPC sending that data, that all has to be tested and verified. These data have to be stored within our existing structure in an infrastructure that works and doesn't cause anything else to break, and we have to test all of that. Once all that is tested, everything seems to be working as we expect. It has to undergo a full test run with our operations team and get approval from a number of different levels and a number of different groups. Once it gets that green light, it'll move on to an official evaluation. But what I hope we know, sitting in this room, is that milking speed did get that ultimate green light, and it was released as an official evaluation in August of 2025. So let's take a look at what those official results look like. The PTAs that you'll see are a Holstein phenotypic average of 7 pounds per minute, and that distribution in the center of the slide is the milking speed PTA distribution from August 2025. You'll see our peak is right at about 7. As we move to the right and we get larger values, those are going to be our animals that are faster milkers. They're producing more milk per minute. We move to the left, smaller values, those are going to be our animals that are slower milkers. They're producing less milk per minute. And if we're looking to improve our parlor efficiency, those might be the animals that we are looking at to either not select for the next generation or to remove from the herd. When we looked at the relationship of of milking speed with other traits that we select for, the only significant correlations were with milk yield, and because of that correlation with milk yield, we also saw a relationship with somatic cell score and mastitis resistance. You may also want to know how all these milking speed tools that are available compare. So the first thing that we should note is that milking speed has been available for brown Swiss and milking shorthorn historically, and they will continue to be available for those breeds. However, these evaluations are based on subjective data taken during the type classification. So they have a separate data source, and it will be abbreviated MSP for those specific evaluations. We've also compiled a table that describes a lot of the differentiating factors between some of these milking speed tools that are available. I know this is very small on this table, but you can go check it out on our frequently asked questions page for milking speed. And we also have a trait page for milking speed that has a lot of the just trait-specific characteristics that you can learn more about the trait. So with my last few slides, I wanted to talk about, well, what now? What's next for milking speed? So the U.S. dairy industry now has a new genetic tool to distinguish animals based on their genetic milking speed. We're now able to identify those slow milkers and make some decisions based on that. And given that we don't really want to move the population one way or another, there are no current plans to incorporate milking speed into net merit. It'll remain a separate trait similar to something like gestation length. For future work, I've kind of divided this into kind of our easy opportunity and our more challenging opportunity. Easy, as more data come into the National Cooperator Database, we can expand these evaluations to other non-Holstein breeds. The more challenging step forward is going to expand this work to use automatic milking systems. When we start to look at that, everything gets a little bit more complicated. We have many more factors to consider. The milking frequency then varies on a cow and day basis, as well as the interval in between her milkings. We need to be careful that we appropriately account for that. Currently in the National Cooperator Database, we do have some data available for researching that. We have about 20,000 cow lactations with data from AMS. So before wrapping up, I would be remiss not to acknowledge all of the partners that had a hand in making this evaluation possible. First and foremost, the dairy producers contributing these data, and then also our member sectors and collaborators, specifically DRMS, for compiling the data and making the research possible, and all the members of the Milking Speed Task Force across the industry. USDA Agile led a large portion of the research for this trait, and then CDCB staff had a large role, many members, in making this become possible. If you want to learn more about milking speed, I've compiled a list of resources, either produced by CDCB or some of our partners. These are great references to go check out. These slides will be available, and you can follow the links as you care to. And with that, I'd be happy to take any questions.
Thank you very much, Kristen. We do have a couple of questions for you. Sorry, I'm trying to show up so you can see me.
There you are.
Hello. So there are a few questions floating around here. We're going to appropriately distribute them to the correct speakers. So they are not about milking speed right now if you look through the list of questions that are floating around. But milking speed questions for you, Kristen. For milking speed, have you looked at the averages of the flow rate over days in milk to potentially account for this in the model?
Yes, we have. I believe it follows kind of a typical lactation curve. I don't remember why we haven't included that. I'm sure there's a reason that I just can't think of right now, but yeah.
Okay, fair enough. Can cows milk too fast?
I think that's a tricky question. There is some evidence that cows milking too fast may have an increased susceptibility to things like mastitis. So that would be one thing I would be careful of.
And then do we expect, or do you expect, to have an impact on behavior from selecting for milking speed?
Ooh. I don't know, I've never actually thought about that, but that is an excellent question.
Yeah, me neither. I thought that was fun. All right, I think that's what we have in here for now. So thank you, Kristen.
Okay, thank
Kristen will be
you.
available for questions later on as well.